Hello, everyone, and welcome to this LumiKnow Tough Enough series where I'll be solving questions which are pretty hard, and some of them will be past papers, and some can be difficult physics topics also. So this question paper that you are seeing is not the original question paper, but this question paper has been recreated, and this is a May 2026 question number 4. Right, this question came in May 2026, and this is question number 4, which is a criterion B and C type of question in which we study about a spring launch investigation. So let us try to understand and answer this question. If you have written this test, and if you remember you have written this test, please do like this video. And if you are writing the test next year, e-assessment next year, please, you must follow this channel so that you will be aware of how to write e-assessments. Now, right, let's get into the question. Now, this is a quick walkthrough. So you can see here, this question is asking a student interested in exploring how springs can be used to launch object. The student uses a toy car, spring, and an inclined track. The student can change the distance of the spring that is compressed before the toy car is launched up the inclined track. The student wants to investigate how the distance the spring is compressed affect the maximum height of the toy car that reaches in the inclined track. Now you very well know that when you are compressing a spring and keeping a toy track, as you can see in the image, you are going to have the toy car launched because of the spring's force or because of the spring's energy. So here I want to say what is the research question. So here I'm going to say how does the spring compression affect, right, affect the, what do we have here, maximum height reached by the car, maximum height reached by the car. And one more thing, if you want this particular paper, the same question, you will find that in one of my portal. At the end of this video, I'll tell you where to find this question paper. Now, yeah, so this is my research question, how IV affects DV. So how spring compression affect, okay, how spring compression affect the maximum height reached by the car. I'm very bad at typing, right? So yeah, I'll try not to type much. Okay, now question 4b, you have to identify the IV, DVs, and CVs. Mass of the car, obviously going to be control variable. I'm not going to change it. Angle of incline, control variable. Distance the spring is compressed, yes, that is my independent variable. How the spring compression affects, okay, how the spring compression affects. Surface texture of the track, it is controlled variable. And maximum height reach, of course, that's my dependent variable, and that's how I select it. Now the toy car moves up the inclined surface, as you can see. The spring pushes it and it is undergoing energy transformation. Drag the best graph and represent the energy to the system of each position. Now we are going to see in terms of energy. Now let us see what is the position A here. In the position A, you are going to have the spring compressed completely and the toy car is at rest and there is no height. So all the energy is encapsulated only in the spring force. So you can see the elastic potential energy. So this is for position A. Position B, a toy car halfway to the maximum height. Now when it is halfway to the maximum height, the spring is completely free. So there is no elastic potential energy. No elastic potential energy. It is having some speed and it is having some height, so it is having some gravitational potential energy. This is the graph for it. Finally, toy car at maximum height. At the maximum height, the car is not moving, kinetic energy is zero, spring is not compressed, elastic potential energy is zero. The only energy that has a gravitational potential energy, and that's how I drag it. Now in the actual question, these box where you were supposed to drag to the box, but when I made this thing question, it didn't come in that way, so that's the reason why I have just changed it a little bit. Now formulate a hypothesis that could be testing the relationship between the distance the spring is compressed and the maximum car height. So here you have to talk about how if it's going to increase proportionally, if it's going to inversely proportional. So here, if my IV changes, how does my dV change? So here I have to say, if the spring compression increases, my maximum height reached by the car also increases, because I have to explain the reason. Because greater will be my elastic potential energy, the same energy is transferred to the gravitational potential energy. See, conservation of energy basically. Greater is your elastic potential energy, same energy is converted into gravitational potential energy. Greater is the gravitational potential energy, greater is the height that the vehicle has moved. And that would be your answer here. Now, in the lab, you have range of equipment. Select one piece of equipment that you will need to measure the dependent variable. My dependent variable is the height, right? So I have a ruler, I have a scale, I have a protractor, a stopwatch. Obviously, I have to go for the ruler, the scale basically. Right? The scale here, it is a different scale. So what I'm looking for is a ruler. Okay, I don't require stopwatch, neither I require protractor. Now, after collecting the data, the student presents their result in the form of a graph, and you can clearly see that this is not a straight line. This is not even a straight line. Now estimate the height of the car that would reach if the distance of the spring is compressed to 0.38. Okay, now if the distance is 0.38, now what will be my maximum height? You have to check here what will be my maximum height. 0.38, 1 2 3 4. If it is 0.38, my maximum height is going to be approximately somewhere near to this point. So it's going to be 0.0 0.0 1 2 3 1 2 3 4 5. So it's each 5 are there, so 3, it's 0.56 is the answer. 0.056 meter is the answer here. Right. Now the student makes the following claim. As you can see from the graph, there is a direct proportional relationship between distance of compression and maximum height reached. Using the graph, part F outline the validity of the student's claim. Now you clearly see here it is not a direct proportionality. You can see that the line is going through the zero, but it is not a straight line. When it is not a straight line, it is not a direct proportionality. Here the line is not straight, and you cannot call it as direct proportionality. Okay, so but it does increase, but not a direct proportionality here. Okay, so that's why you can explain that in the graph. Now here you can see a straight line, but this is a graph between maximum height versus the square of the compression. But see, look here, when you're taking the square of the compression and maximum height, you are going to get a straight line. Okay, and I can see that here, but what is the question asking here? The question is asking calculate the gradient of the line of best fit, and you must also include the answer. Now the gradient, okay, so while I say the gradient, I have to find the slope of it. Okay, I have to find the slope of it. So you can clearly take this as 15, x as 15, and when you have, let me take a appropriate value that will get me a nice proper answer. And this is going to be 1 2 1 2 3 fourth line. So 3 to 4, so 0.50 plus 12, so it's going to be 0.62. So my answer is going to be 0.62 by 15. Let me take my calculator. Yeah, 0.62 by, okay, 0.62 by 15, and that's going to be 0.004133. 0.004133. And what would be the unit here? See, it is meter by meter, and this is the square, meter by meter square. So it's going to be meter power minus 1. Meter by meter square, right? Maximum height is meter. Square of the distance is meter square. So meter by meter square is meter power minus 1. So the gradient of this line is giving you 0.004133 meter per meter. Okay. Now the question here asks, after doing some research, the student learns the elastic potential energy stored in the spring is E is equal to half kx square, right? Now, and according to conservation of energy, I told you about this, right? This is the game of conservation of energy. So mg delta h is equal to half kx square. So your potential energy, your elastic potential energy, which is half kx square, is equal to mgh. Now, what is represented by the graph then? Okay, but so use the relationship shown here. What is represented by the gradient of the graph? So basically, the gradient of the graph is somewhere around delta h by x square, right? Delta h by x square. So you do here, you look here, you just do a little bit of calculation. Keep your delta h here, x send x square downwards. So you will have k by 2 by mg. K by 2 by mg, and that's my answer B. So look here, simple. What is slope? Slope is y by x. What is my y? Delta h. What is my x? X square here. Okay. So what is my delta h by x square? Send x square down. So you have half k and send mg down. So k by 2 mg is the answer here. Finally, suggest variables that student could use to extend their investigation. The dependent variable has been completed for you. The dependent variable is maximum height reach. Okay, now I need to extend my investigation. That means I can change my IV CVs. So what I can do here, so now this is your complete judgment. What I can do here, I can do type of spring or spring. Now, why type of spring? Because different springs will have different spring constant and will create different forces. Control variable, as usual, the surface I'm keeping. Another control variable, as usual, I'll keep is the angle, and that would be my answer. I submit it. Right? So, yeah, you see, you will get the feedback of the questions which are subjective based, not which are optional based, which is like MCQ. You will get the instant feedback for that, and the questions that you are typing, you will see the response here, but you will not get an and you will be getting the expected answer here. Okay, you will be getting the expected answer here as your requirement. Okay, as you can see here very clearly. So students, this particular question is available in my free course portal. As you can see, my all YouTube material you will be finding here, and all the content that I'm using for my YouTube, where I'm explaining about IB, and the questions that I'm using here you'll be finding here. So the link for this particular course is given in the description. I want you to go through it. Please utilize that course, this whole free course for you. Please learn it, utilize this to the fullest extent. So with that, I will end my session. We will see in the next video. Bye.